Good afternoon. I'm Alvin Deang. I'm going to present the abstract data type and its implementation. So, what is abstract data type? We know that data type signifies the type and space taken by the data used in a program. An abstract data type is a special data type that is defined by a set of values and a set of operations on that type. Okay. We call this data type as abstract because these are independent of any implementation. We can use these data types and perform different operations with them, but we do not know how these operations are working internally. The implementation detail of these data types are totally invisible to the users. It does not specify how the data store in the memory area and what algorithms are useful for implementing the operation on that data. An abstract data type in the Java is useful in the implementation of data structure. Java library provides various abstract data types such as list, stack, queue, set, map as inbuilt interface that we implement using various data structure. So data types, Java abstract data types can be, we can classify the abstract data types either built-in or user-defined or mutable or immutable. If an abstract data type is mutable, then we can change the object of its type, and if it is immutable, then we can change its object. For the operation, we have creators, producers, observer, and mutators. Creator will create new objects of the type. It may take an object as an argument. Producers create new objects from old objects of the type. For example, the concat method of a string is a producer that takes two strings and produce a new string representing their concatenation. Observer takes the objects of the abstract type and returns object as a different type. For example, size. The method of the list returns an int. Mutators means mutators change the object. For example, add method of a list change a list by adding an element to the end. So here are the sample of abstract data types along with some of their operations and types. So int is a primitive integer type of Java.
Meron na.
Mutators. Operators are creators will be numerical value. Producers will be addition, subtraction, multiplication, and division. Observer will be the comparison operator. Is the equal sign, not equal sign, less than, and greater than. So it is not immutable. So for the list is an interface of Java list. The list is mutable. Its operations are for the creator will be array list and linked list constructor or collection singleton list. So the producer will be collections and the observer will be size, get, and the mutator will be add, remove, add all, collection or collection sort. And another one will be the sample will be string, or a string is a Java string type. The string is also immutable. Its operation are string constructor, and the producer will be concat, substring, two uppercase, two lowercase, and the observer will be len, carat, and it also immutable. The list of Java abstract data type. So we have list, stack, queue, set, and map. I'll be focusing on the list abstract data type, stack abstract data type, and queue abstract data type. So for the list abstract data type, the Java list interface or the java.util.list represents an order sequence of objects. The elements contained in a Java list can be inserted, accessed, or iterated and removed according to the order in which they appear internally in the Java list. The ordering of the element is why this data structure is called a list. Each element in the Java list has an index. The list element in the list has an index 0. The second element has an index of 1, and so on. The first element is the 0 element away from the beginning of the list because it is the beginning of the list. You can add any Java object to the list if the list is not typed using Java generics. Then you can even mix objects of the different types in the same list. Mixing objects of the different types in the same list is not often done in practice, however, it is possible. Example, you're going to add numbers on the list and you're going to put string on the list. So what is the difference of list to set? Java list and Java set interface are quite similar in that they both represent a collection of elements. However, there are some significant differences. These differences are reflected in the methods the list and the sets indicated offer. The first difference between the Java list and the Java set interface is that the same element can occur more than once in a Java list. This is different from the Java set where each element can occur only once, so no duplicate. The second difference between a Java list and the Java set interface is that the element in the list has an order and the element can be iterated in that order, while a Java set does not make any promises about the order of the elements kept internally. So let's now go to implementation of the list. So I'm using the Eclipse. So we have sample here for the list demo. So being a collection of type of method in a collection interface are also available in the list interface. Since the list is an interface, you need to instantiate a concrete implementation of the interface in order to use it. You can choose between the following list implementation in the Java application. This is the sample. Okay. So to implement the list, we can use java.utility.list or java.utility.linklist or java.utility.arraylist. Okay. Now to create, you can create lists by using this code. You create list instance by creating an instance of one of class that implements the list interface. So this is the sample. We're assigning list A as new array list and the list B will be a new linked list. Remember, most often I will use the array list class, but there can be cases that using one of the other implementation might make sense. Now we can proceed to the next example. This is the inserting of new elements in the Java list. You may insert elements into a Java list using the add method. So this is the sample. You can directly add the value to that uh, to the variables, or you can on the variable then assign to the list. So let's run this one for you to view. So first we assign, or we add element 1, then we add another element 2, then the next one will be we assign E1. So what's the value of E1? It will be element 3. So the output will be element 1, element 2, and element 3. So that is how to use the add method in list. We can also add a null value to the list by simply using this code. First, we assign null value to the object, and the object will be added to, or the value of that object will be added to the list. So, try this on the list. It is possible also to insert element into a Java list at a specific index. The list interface has a version of add method that takes an index as first parameter and the element to insert as the second parameter. So this is the sample. So inserting element as a specific interface. Let's run this one. So element 4 is added at the index 3. So let's try to change this one. So element number 4 will be added at the index 1. So indexing starts with 0, 1, 2, 3. Okay. So try again. Let's. Okay. So try this one. So element 4 is added at index 2. We can also add all elements from one Java list into another Java list. You can do this using list add all. This is the sample. So first we declare variable list source to get the first value or the value. Then it will be transferred to the list destination. So by using this code, we're going to transfer the value of list, or we're going to copy the value of list source to the list destination. So let's try to run this one. So printing will be list destination. The value of list destination will get the value of list source, which is 1, 2, 3, 4, 5, 6. You can get element from Java list using index of the element. You can do so using either get index method or this is the sample. Okay. So first we have added apple, banana, and cherry to the list. Then we're going to get the value of this index, which is 0, and put it on the element 0. The index 1 will be added to element 1. Index 2 will be added to element 3. So print out list A. So what is list A? List A is this one, which is apple, banana, and cherry. Okay. So the output will be apple, banana, and cherry. So print element 1. What is element 1? Element 1 is please get index 1. So what's the index 1 of the list will be banana. So the output is banana. Then next one is print list A dot get index 2. So index 2 will be cherry. So that's why the output is cherry. Also check the Java list if it contains a given element using the list contains method. So here is the sample. So we have added the list of apple, banana, cherry, banana, and durian. So I'm going to locate the index of apple on the index 1, and we're going to locate the index of durian, and it will be added to index 2. So let's try to run this one. So what's the index of apple? It's 0. So the result is 0. And what's the index of durian will be 0, 1, 2, 3, 4. So the output is 4. And the next one will be the last index of. So as you can see, I have a sample here. We have 2 banana. So if we're going to search the last index of banana, it will not get the first index, or it will get the last index, which is 0, 1, 2, 3. So it's 3. So the last index will be 3. Okay. We can remove elements from Java list via these two methods, which is the remove object element and remove by index. This is the sample. It's either okay. So the sample will be how to remove the value. Okay. So first we added apple, banana, cherry, and durian. So if we're going to print this one, it will be apple, banana, cherry, and durian. Then the first is removing elements from the Java list using elements. So we're going to put remove apple. So if we're going to print it, the apple is removed. Then the next one, remove elements by using an index. So index 1. So what's the index 1? So the index 1 for this is cherry. That's why cherry is removed. Then another one, we have the remove all element. Remove element, we're going to use the clear method. So list that clear, it will remove all the value inside the list. So as you can see, nothing left. In Java list interface has a method called retain all, which is capable of retaining all elements from one list which are also present in another list. In other words, the retain method removes all the elements from the target list which are not found in the other list. Resulting is the intersection of the two lists. So here is the sample. Sample is we added apple, banana, cherry, durian, and cherry to the list. Then we're going to retain only banana, cherry, and durian. So list that retain all from the other list. So it will remove apple and apple only. Okay, so let's try to run this one. So apple was removed because it is not present on the other list. The only value will be retained will be which is inside the other list. Okay. Let's try to remove the cherry. So cherry also is removed from the list. Okay. So we also have a method of size which will uh, tell us the number of elements in the list by calling the list size method. Okay, so this is the sample. It will just output the size of the list, which is here we have added two elements, which is object 1 and object 2. So if we're going to get the size, so list that size method. So we're going to print the size. It will output 2. Okay, because we only added two elements, which is object 1 and object 2. In Java interfaces, a method called sublist method, which can be create a new list with a subset of elements from original list. Example, we have this one. The sublist method takes two parameters, a start index and the end index. The start index is the index of the first element from original list to include into the sublist. The end index is the last index of the sublist, but the element of the last index is not included in the sublist. This is similar to a Java string substring method. Let's try to run this one. So first we have the element we have the list element will be element 1, 2, 3, and 4. We have element 1, 2, 3, and 4, and we're going to get a sublist from index 1 to index 3, which is 2 to index 1 is here to index 3. But again, the last index is not included. So it will be from index element 2 to element 3. Only element 2 and element 3. Okay. Now, we're going to convert the list into set or into array and into a list. So it from array to list and list to array, we can do that, or we have that option. So this is the sample. So converting the list into set, we have first we're going to create a variable set, which is the hash set, and set will get all the value of the list. Okay, so let's try this one. So the value of the list, which is 1, 2, 3, 3, it will be added into the set, and we will put again the function of the set. It will not get a duplicate value. So the element 3 will get only one value, and it will not get another value which has already added into the set. Then another one, we're going to convert the list into array. So we're going to create an object 1, and it will get the value of list into array. So it will get the value of element 1, element 2, 3 and added into the objects. Okay. The next one will have the convert array into list. So first we have declared value as a new string array and gets the value of 1, 2, and 3. So to transfer this value into array, we have declared list2 will get the list string array as list, which is the value this variable. Okay, so it will get the value 1, 2, 3 and put it into list2. So if we're going to print this one, the output will be 1, 2, 3. Okay. Then we have the sort. You can sort the Java list using the collection sort method. So let's try the sample. We're going to run. So first we added the value C, B, A, and as you can see it output C, B, A. Then we run the sorting collection.sort, which is going to sort the list. So then print out the list. It will be sorted. So it's A, B, C. Now we can iterate the Java list in several different ways. The three most common ways are using an iterator, for each loop, and for loop. This is a sample. So we have first we had added the value which is first, second, and third into a list. Then we're going to iterate it using an iterator. So this is the code for the iteration using iterator. So as you can see, it will output first, second, and third while looping. Then the other one will be using for each loop. So we have the for each loop is the same. It will output first, second, and third using this element and using this code or using this syntax. And the next one will be using the using for loop. Okay, so using for loop, we're going to use this code. Okay, so while looping, so it started from 0 to the size of the list. Then it will get the value of list depending on the value of I. So the I value is 0, it starts from 0 and increment by 1. So again, it will output first, second, and third. Okay. So that will be for the list method. List ADTT or abstract data type. The next one will be stack data type. The Java stack class is a classical stack data structure. You can push element into the top of the Java stack and pop them again, meaning read and remove the element from the top of the stack. The Java stack class actually implements the Java list interface, but you can rarely use the stack as a list. Example, perhaps if you need to inspect all elements concurrently stored on the stack. Please note that the Java stack class is subclass of vector, an older Java class which is synchronized. The synchronizations adds a small overhead to call all methods of a stack. Additionally, the vector class uses several older parts of the Java, like the enumeration, which is superseded by the iterator interface. If you want to avoid this issue, you can use the Java DQ as a stack instead. Okay. So a stack is a data structure where you add elements to the top of the stack and also remove elements from the top again. This is also referred as the last in, first out, or we call it LIFO principle. In contrast, a Java queue uses a first in, first out principle where elements are added to the end of the queue and removed from the beginning of the queue. Well, now, let's try to create a stack. So, let's go back to the sample for stack. We have this one. To implement Java stack, we are going to use the java.utility.stack. Okay? Then you can create the instances by using Java, then string, then new stack as a string. Okay? So you can create using that code. Now, we're going to put an element or add a value to the stack. Okay. And adding a value, you can use the push method. You can push element to the top of the stack. Thus, the element you push onto the stack must be Java object. Thus, you actually push object to the stack. You push element into the Java stack using push method. So here is the sample. We have added 1, 2, 3. So let's try to print out this one. So it added 1, 2, 3. Okay. So let's try another one. Natin to. We have 4. So again, 4 is added on the stack. Okay. Then we have to get the value or to pop up the value, we can use the pop method. So, using a pop method, it will remove the first or the last inputted, which is last inputted will be 4, so 4 will be removed. So that's why 4 is removed, and when we print it out, it will be only 1, 2, 3. We can also use the pick method, or we're going to pick the pick without removing or viewing without removing the value. We can use the pick method. So in pick method, we can simply put this one, stack.pick. It will show us the element on the top, which is the element on the top will be 3. So the output will be 3. Okay. We can also search for an object on the stack to get the index using the search method. The objects equals method is called on every object of the stacks to determine if the search for object is represented on the stack. The index you get is the index from top of the stack, meaning the top element of the stack has an index of 1. Okay, so here is the sample. We have 1, 2, 3, 3. 1, 2, 3 will be added on the stack, and so let's run this one. We have 1, 2, 3 added on the stack, and we're going to search number 3. So number 3, so the index of number 3 will be 1. So it's 1, 2, 3. Okay. Let's try another one. We have put 2. Okay. So it's 1, 2. Try the 1. from the top to bottom. Okay, and we can also get the size of the stock using the size method. So we have stock the size. So the size will be 1, 2, 3. So it output 3. Okay. So we can also iterate elements of the stock by using this code. Okay, we have using this code. Okay. So let's run this one. It will also print. Okay. The iterator gets the value of the stocks each loop. Okay, so the first loop will be 1, 2, 3. The second loop will be 4, 5, 6, and the third loop is 7, 8, 9. Okay. The next one, you can use a Java stack to reverse the Java list. You do so by pushing all elements from the list into stack, starting with the element of 0, then 1, etc. Each element is removed from the list, then pushed into the stack. Once all elements are on the stack, you pop the elements of one by one and add them back to the empty list. Here's the sample code. So we're going to have a list that holds the value of A, B, C. So we have another one. We're going to declare stack that will get the value of the list. So stack will get or push the value of the list index 0 to index 1, and at the same time it will be removed on the list. Okay, then the next one will be getting the value of stack or adding the value of stack, and at the same time removing it onto the stack. Okay, so let's try to run this one. At first we have is ABC, ABC, so print ABC, so the output will be ABC. Then it will be added on the stack, and at the same time it will be returned to the list. So that's why the output will be CBA. It will be reversing the value. The last one will be the QADT. The Java Queue interface represents a data structure designed to have elements inserted at the end of the queue and elements removed from the beginning of the queue. This is similar to how queue is in a supermarket works. The Java Queue interface is a subtype of the Java collection interface to represent an order sequence of an object like a Java list. But its intended use is slightly different because the Java Queue interface is a subtype of Java collection interface. All methods in the collection interface are also available in the queue interface. So, for the implementation, again, let's go back to the Eclipse, the queue demo. So, for the Java queue implementation, we're going to use, since queue is an interface, you need to instantiate or concrete implementation of the interface in order to use it. You can choose between the following queue implementation, which is the java.utility.linked list or the java utility.priority queue and the java utility.qr. So linked list is pretty standard queue implementation. Elements in a queue are stored internally in the standard linked list data structure. So this makes it fast to insert elements at the end or the tail of the list and remove elements from the beginning, which is the head of the list. The priority queue stores its elements internally according to their natural order. If they implement comparable or according to comparator pass to the priority queue. So here also the implementation package, but I will leave the concurrency utility out of the tutorial. So here is the sample on how to create the queue instances. We have queue, and the QA will be created as linked list. QB also will be created as priority queue. With most queue implementation, the head and the tail of the queue are at the opposite ends. It is possible, however, to implement the queue interface so that the head and the tail of the queue is in the same end. In that case, you would have a stack. Okay. So, how to add an element to the queue? The Java queue interface contains two methods you can use to add element to the queue. These methods are the add method and the offer method. These two methods add an element to the end of the queue. The add and offer methods differ in how they behave in the queue if it is full. So no more elements can be added. The add method throws an exception, so meaning it will prompt an error, while the offer method just returns false. So let's try this one. First, it added the value of element 1, and then the next one it added element 2 to the queue. So we print the queue, but it will output element 1 and element 2. Okay. Now to remove a value into a queue, we're going to have this method. So in removing an element to the queue, you can call either poll or remove method. The poll and remove both removes the first element in the queue. So they differ in how they behave if the queue is empty. Okay, so let's try this one. First, we added element 1 and element 2 to the queue. So let's print. So we have element 1 and element 2. So it will be printed. Then first we are going to remove the first element. So we'll remove, as you can see, the first element is element 1. So once we print out, element 1 is removed. Then next one, we're going to have remove element, and another one we're going to call remove. So the first element will be removed, which is 2. So 2 will be removed, so it's empty. Now let's go back to the behavior. So removing an element if it is empty, like this one, it will, okay, so the poll will prompt us an exception. So it will create an error. While, wait, even though this one is 2, sample is 2. So print, okay, 3. We're going to run this one. It will not create an error, an exception. While using the remove button, we're going to use the remove button. It will prompt an exception. Okay, it will create error message. While using poll, it will just uh, output empty list, empty queue. We can also use the pick method on queue without taking the element out of the queue. So here is the sample. We have the queue.pick. Okay, queue.element. Let's try this one by using queue.element or queue.pick. We added 1, 2, 3 to the queue, or element 1, element 2, and element 3 to the queue, and we're going to pick the element. So the first element will be picked. So the first element is element 1, so it will output element 1. So first element will be output. So that's why element 1 is outputted. We can also use the pick method. So in pick method, it will also display the first element. So first element is element 1. So element 1 is printed. Now to remove an element from the queue. So we can simply use this code. Okay. The remove method and also the clear method to remove all elements. Okay. So if we're going to remove, let's run first. Right, outputted 0, 1, 2. So 0, 1, 2. Then we're going to remove we're going to prompt the remove method. So what is the value to be removed? It will be the first element, which is element 0. So element 0 will be removed. So print natin, element 0 is also removed. Now, we can also use the clear method, which clears all the value. So element 1 and element 3 will be cleared. So, when we print the queue, it will be empty. Okay. So get size. Again, it's the same. We can also get the size of the queue. So by simply using this one, the size method. Okay. So let's try this one. So we have added Mazda, Honda, Toyota. So what's the size of the queue? We have 1, 2, 3. So it will be outputted 3. Okay. Then we also have the or checking the contains, or checking will display the index of the that contains the element. Okay. So Honda here. So what's the index of Honda will be or it will check, it will check if the value Honda is in the list. Okay, it will display the a Boolean expression which is true or false if the elements is in the list. Okay. So as you can see, Honda is in the list, so it will output true. Let's try to change this one. Ferrari. Ferrari. So it's false. Ferrari is not in the list or in the queue. Mazda. Let's try Mazda. So it's true. Mazda is in the list. Okay. We can also iterate the elements in the queue by using this code. Okay. We can use this via iterator or via for loop. Okay. So we have added element 1, element 2, element 3. So let's try to run this one using an element, iterate all elements using iterator. Have this one. So value will display the value of q for every while loop. And the next one will be display the element of the q in every for loop. Okay, so same 0, 1, 2. Here again 0, 1, and 2. Okay, so that's all for my report. Again, thank you and a pleasant day